Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 57. Yeah, I know I'm going over, but I'll probably keep doing stuff as long as I have things to talk to you about and as long as you seem interested in it. What are we talking about? In this lesson, we're talking about distributing, monitoring, and worker functionality. What do I mean by that? I mean running all of these monitors and worker functionality on an entirely different system. You can see I've labeled it Raspberry Pi. That's because I purchased a Raspberry Pi specifically for this purpose, and I'm running it remotely even as we speak. That means over here we have just the Flask application that is our quokka-server running. It's listening for HTTP requests. It's using a message broker to communicate worker requests to the workers. Why do we do this remote? Because we can distribute the labor, number one, across multiple systems to achieve horizontal scalability. We can also, a lot of these things require proximity to the thing that it's either monitoring or scanning or what have you. And so you want to be able to place these in locations that is going to make that easier. So that is why we're doing this. That's one reason why we're doing it anyway. Another thing that we will talk about is the fact that, yeah, you can actually have your server running in a different spot from where your monitors and workers are working. So you can do this. Something I don't even mention in the lesson is, of course, you can have the internet between your user interface and the Quokka server as well. But we're talking about distributing this functionality. That's what we will do. We'll talk a little bit about why. We'll talk about why we're able to do that, mainly because we're using HTTP. We'll talk about how much code had to change, which is hardly anything because of the design decision that I made early on to send data back to this particular Quokka server service using HTTP. That means it's very easy to do it remotely. In fact, I didn't have to change anything other than removing the hard-coded localhost into the actual IP address of the remote Quokka server. But I'm getting ahead of myself. That's what I'm going to be talking about. So hopefully this will make sense to you and you'll enjoy it. So let's get started. Okay, let's talk about what we mean when we say we want Quokka to be distributed, or we want it to be remotable, or we want to run some of the functionality, and specifically these monitors and these workers on a different system. What are we talking about? Well, if you look at this picture, which is the one that we used when we talked about packet capture, you'll see that the user interface that you see here, you'll know that that can be run on any system because that's just how browsers work. They use HTTP and they come through the web server and it gets the information and it prints it out, etc. What you may or may not have realized, but what I attempted to point out, and I'm not sure if I did a good enough job of that, is the fact that these applications also use the REST API. In fact, they use the REST API to send data to the Quokka server, which then puts it into the database so that the user interface can get at it. In the same way, these workers run and they gather port scan information or packet capture or traceroute information, and how do they give it to Quokka? Well, they use the RESTful API and things get stored into the database. Now, what does that mean? What are the ramifications? What that means is that these communication path can exist across different systems. So you can actually be running the Quokka server on one system, and you can be running these monitors or these workers on another system. And here's another thing of interest that may be of interest to you. You could even be running the database on a different system. That's an entirely different question, but as you're probably aware, databases do tend to run on their own system. So just so you know, this is a common thing in software, and that is that you have distributed applications that have functionality that's running in different places. What does that look like? What it looks like is something like this in this particular picture. Now, over here you can see there's a different system. I've named it Raspberry Pi simply because I purchased a Raspberry Pi on which to run my workers and my monitor functionality and that's what's actually feeding the data that you see down here in this user interface where we're looking at this Quokka data that's coming from the Raspberry Pi. How is that working? Well, as I mentioned, we are sending the data via HTTP to this REST API, and it works exactly the same as it did here. The only difference is the earlier versions of this code and stuff that you may have looked at if you've looked at quokka-prime or any of the 52 weeks of Python stuff we've been doing. I hard-coded to send stuff to localhost on whatever port I decided what I've had to do, and this is what I possibly should have done from the beginning, is I've added to the functionality to these particular applications that run so that I pass in where is the quokka-server located, so the IP address and the port of that, and then that's used to do this HTTP request. So no code changes other than getting rid of the hard-coded stuff and taking as an argument passed to these applications the actual destination that will be used to send this data. And as you see in this picture, this Raspberry Pi is actually running, and it can send the data to the Quokka server. One thing that I haven't mentioned is how does the requests, remember our workers are listening on a message queue, so this also works across different systems. It's not HTTP, it's a different protocol entirely, but it uses a port for communication across the network, and this Quokka worker listens on the particular queue for this message broker, and it sends work requests out to these threads that it creates, and they then send the data back to the Quokka server. So not only the monitors sending data to the REST API, but also the workers send the data to that REST API. The difference being over here on the left-hand side, these workers are a little bit different in their nature. They sit and do nothing until they are requested to do something. That's why they're called a worker. They'll sit there and wait till a request comes in to do work. They will do the work, and then they'll go back into effectively a dormant state. In reality, what happens is the thread gets created, it runs, and it completes. But that's basically what it does. These things over here, these monitors, are up and running all the time. They don't require a request to come in from any message broker or anything. They're just going to run, and they're going to forward their data to the Quokka server. So in a sense, they're a little bit easier in terms of the implementation, and we will begin to look at that and look into this in more detail in the next segments. One thing I do want to show you is this, just so that you know I'm not pulling your leg regarding running on the Raspberry Pi. Here is a picture of the Raspberry Pi that I purchased. It is a Pi 4. It has 4 gig in it, as it turns out, for running all the things that I showed you in this picture over here on the right. I'm using less than 1 gig, so I probably could have gotten away with having the 2 gig version, but that is the actual device there. If you want to see what it looks like, this is my entire desktop. You can see, you may or may not recognize this. I'm running Kali Linux. I did replace the Raspberry or whatever they call their own Linux OS with Kali, because I want to be able to do sniffing and other type stuff on it without too much difficulty, maybe run in promiscuous or monitor mode for my Wi-Fi. And so I went ahead and booted Kali Linux on it, and I put all of the software for quokka-prime. I downloaded it, loaded the software that I need for this functionality, things like SCAPI and Nmap and things of that nature. And yeah, and then this is where it's running, and it's actually passing the data along. You can see down here in the corner that's the mouse pad for my laptop. My laptop's over there to the left, and it is running a VM in which the Quokka server is running. So this is my remote system right here, and over here on the left is where my actual Quokka server is running. So yeah, that's what I'm doing. Let's next take a look at what we're doing on that Raspberry Pi. So here we are on the Raspberry Pi. Down here at the bottom right, this is the monitors directory. I'm looking at the run monitor script that I've created. You can see that I'm going to be passing in a parameter. That is going to be the Quokka service that is running. It's a web service, so I need to provide the port on which we will be sending these HTTP requests that will contain our data. And what I'm going to do now is I'm going to run that script. I'm mistyping Quokka. I don't need to type that in. I just need to give the actual IP address and port of the location to which the information from these monitors will get set. And so remember, I need to provide the port here, and it needs to match whatever the quokka-server is running on in our Flask quokka-server application. So you can see I'm highlighting that there. Once I run it, it's going to begin to run all of the monitors at once. If you look down at the bottom left, you will see that the CPU is going to spike because all of the monitors are beginning to run at the same time, and they are executing. We are discovering hosts. We are communicating with services and devices. We're beginning to do host port scans. And so all of this stuff is actually going on. You can see the memory is not getting used all that much, even though we're doing all this functionality that's running at this time. And that was where I mentioned that I didn't need the whole 4 gig. But you can see that that's going along and running fine. So what we're going to do now is look up at the top left. And at the top left is where I'm actually going to be running the worker. And so at this point, I'm going to look at the run worker script that I created. You'll see that there are 2 parameters that I'm passing to it. One is the name of this worker, and the other is the broker. The name is important. What I'm going to do now is I'm going to show you on the server where you configure the name of the worker to which the request will get sent. So I've created a YAML file that has an IP subnet, and in it I have the worker name, and that's actually the name that we'll be providing when we run on our Raspberry Pi. The broker is actually just the IP address of the broker, the message broker, which is running on the same system as the Quokka server. So in this situation, I'm typing in the name of the worker, that's home subnet as we saw, and now I only need to type in the IP address of the broker. Remember, I don't give the port because the port is not important. The port is going to be whatever my message brokering service is using. And so here you can see that it says we are actually listening on the queue called home subnet. That's the communication. Now you just see a bunch of stuff. That's because I went over to my Quokka server and I requested a packet capture for this IP address that you're going to see. You see I don't have a protocol specified or a port, but I do have an IP address that it's going to listen on. And so at this point in time, we're waiting for something to happen. As you can see down here in my monitor, we won't see anything happen in terms of packet capture until we actually see the device monitoring begin to happen. So we're just waiting here for that to occur. And here you see some stuff beginning to happen. You can see that we've retrieved devices. We're updating device status. We're getting all these packets. I tried to highlight stuff, but you can't see it. What I really wanted to do is highlight this, which shows you that, yeah, that's when we went out to get the device status. And in this particular output, you can see there's a whole bunch of stuff that is happening. So a whole bunch of packets are getting sent back and forth between this Raspberry Pi that's running the monitors and that IP address, which happens to be the IP address of one of the Cisco devices out in their sandbox. So here's a graphical image of what I was just trying to demonstrate. We looked at the Raspberry Pi and we saw that we did run monitor, and all we needed to do is pass in the HTTP URL beginning portion in order to allow me to communicate with my remote Quokka server. And then for the workers, what I needed was two things. One was the name of this particular worker system that it was running on. I called it home subnet. You could have one of these for each subnet if you're running, and that would be the way that you communicate directly with the worker requests that come in. In other words, the request comes in for work, we figure out where it needs to go, and then we put the message in the queue, and the Quokka worker reads from that queue and begins to execute this particular functionality. And remember, we passed in two things when we ran the script that started the worker. One of the things we passed in was the name, which was home subnet, and that's how we identify the queue. The second thing that we passed in was just the IP address of where the broker lives. And with that information, I can listen. And just as an aside, I actually, in the request, I put the URL for Quokka. In other words, the thing we had to type in here, I put it in the worker request. So when we send this back to the Quokka server, that information comes from the request. That's just how I chose to do that. So that is basically what we've got going on here. Now the question is, what had to change in order to for that to happen? Almost nothing had to change. My RESTful APIs are exactly the same. The database is the same. The setting up of the message queue was a little bit different, just to handle that thing, that home subnet queue name or whatever it might be. So there's a little bit of change when we sent a message to the Quokka worker, but for the most part, this remained the same. The only difference is we removed a lot of the functionality. So if we look over here, remember I used to run, I have monitors that were running, and I had workers that were running, and I had the UI that was running, and I had the server that was running. Now I only have the user interface and the server that's running. So basically my server, which is this thing right here, it sits there and receives requests and stores things in the database, or performs a function if it's a request from the user interface to go do a packet capture or a port scan, things of that nature. So basically this is what the server does, and then this user interface application, this npm start, that actually serves up the web pages, and the content comes from the other side, the REST APIs that are served by this Quokka web application that is running, in the REST APIs that I created for it. So that is how it works. Basically no changes other than some minor code changes. So let's look at those minor code changes that I did in order to make this actually happen. So let's dig into this code. As you recall, our quokka-prime project has a number of folders or packages. I have a folder for monitors. That's where things like host monitor, service monitor, device monitor, and the host port scan live. I have workers, and workers is where I have my Quokka worker, which eventually gets run, and then I have the capture thread, port scan thread, trace route thread, etc. If you want detail on these, you can look at where I described them in earlier lessons. But these are the two folders from which the code that's running on my Raspberry Pi is going to come. So basically I'm running my worker and I'm running my monitors over on the Raspberry Pi. On the other hand, on my server, I just have this code. So this basically is my Quokka server, which is a Flask application. Inside it, I have the ability to write to a database. So I have database APIs. I can make requests for things to happen. So I have my worker APIs for sending messages to the workers, things of that nature. And then you can see I have some other stuff in here for utils, etc. But this is the main thing that is running. So in this picture, when you look at this, the main thing that's running is this Quokka service. There's UI stuff, but that's really, I'm just running that. So when you look at this particular set of terminals, this is my Quokka server. You can see it's listening and it's getting requests to update stuff. You can see that I got services and then I updated all the services. You can see I've done the same for my devices here. Here's where I got the devices. So this is my Quokka server that's running over here. This is where I did this npm start, which basically gives us the framework from which we can run our quokka, which is what you see here. So basically the framework for this, and the data of course comes from my web service, which is this quokka thing. So let's look at the code that actually makes it happen, and we're going to start with monitors. Now the first thing I want to show you, here's my run monitors. Remember we looked at that on the Raspberry Pi. This is where I take a parameter called quokka, and then I launch my host monitor, port scan, etc., and I pass in this thing called quokka. Now we didn't pass in anything before when we've been working on host monitor for many weeks, so this is a new thing. And if you were to look at host monitor, you would see that, yeah, I've implemented something to take that argument and to utilize whatever gets passed in. And so that's what we're going to look at next. This is my host monitor. We'll only look at the host just because it's done exactly the same way for the service monitor and for the device monitor. I moved around where my argument parser is. I've got two parameters. One that I never seem to specify is the pool size. Remember when we did concurrency in that lesson and we were creating all these threads, that's where I could modify this. In this situation, I'm not passing anything in, so it defaults to 10 threads to do my monitoring of hosts. And here's the important thing. There's going to be a parameter called --quokka, and that is what I'm going to use. I'm going to take that argument and store it, and then I'm going to use it where? Right here, when I actually, this is a request to get the host, so I'm going to be making my HTTP request, and you can see this is going to be the IP address of where quokka-server is running plus the port on which it's running. So we typed in 192.168.254.158, and that's the IP address of this system here where my quokka-server is running, and I had to put in the port also, so I passed in :5001, and you can see by default it's localhost. So if you don't pass anything in, it defaults to localhost, so you don't have to change how you do that when you run it locally. But when I'm running it remotely, I'll make sure to pass it in, and it will get changed here. Here's one instance where I'm changing quokka, and if I were to scroll down, that's where I'm getting this stuff. When I update the host, you can see it's still highlighted for me. That's where I'm putting quokka. That is functionally the only difference. Now you may look at this and say, wait a minute, your call to request.put has changed. You have this try except. That's because when I run on a different system, I notice that I can have my quokka-server go down, and when it goes down, these things, if I don't have them in a try except, will barf, and my service will actually, my monitor will actually quit running. So this is my host monitor, and it would have quit running unless I put this in here. So at this point, what I can do is I can tolerate the quokka-server going down for some amount of time, and this will keep running and trying to do stuff, but it will fail. But when it comes back up, it will resume operation appropriately. So that's why you see try except around request.put as well as request.get, which is what I'm doing here. So that's the only change. Basically, this was hard-coded before because we just wanted to quick and dirty, or cheap and cheerful, as some say, way of getting this up and running. Now all I really had to do is put in the IP address and the port of the destination, and our monitor is good to go. Now let's look at our workers. So down here, I did modify my quokka worker. So if I go up to the top of my quokka worker here, you can see that I have changed a couple of things. One of the things that you see here is this parameter here that I'm calling broker. And broker is going to be something that if we go down here to the bottom, I have this code at the bottom. I could have put it up there at the top, but it's a global variable that I'm getting from this start request. So here's my arguments that I pass in. I'm going to be passing in the name of my worker. So remember, I had home subnet. If you are running this in a network with multiple subnets and you had Quokka workers on all the subnets, you'd probably want to name them appropriately. Just it's any name you want to do, but it needs to be consistent between the name that you are starting it with and the name that it gets sent to. And we'll look at the file that actually implements that in just a moment. So here's my name, and the second thing is the broker. This is the IP address of the message broker that we're going to connect with in order to perform our RabbitMQ request. Just visually, basically, this is the IP address of this system. That's where my broker lives. And the other thing is, messages are going to get put into a particular queue so that if I have 20 of these different Raspberry Pis running, they will be listening to their own queue appropriately. And that is what that is for. So the queue, which I'm calling the name, which is what you see right here, and then the broker. Those are the two things that I'm going to be interested in. And if we look up here at the code, at my Quokka worker code, you can see that when I connect, I'm going to be connecting to the broker, so I need to make sure I connect to the correct message broker. And when I listen on a worker queue, then I'm going to need to listen on this appropriate thing. And what I called it here was worker name. If we were to go down to where I read this in, then worker name is actually this thing called name. So the parameter that gets passed in this easier version, just -- name, that's going to be my name of my worker. And that's what I will end up using when I connect to the message broker. And for this particular thing, this is all that I need, because if you will recall from looking at this code either in Quokka or in the times that I have described it in the 52 weeks of Python, when I do receive the work request and then I actually do whatever it is that I'm going to be doing, then if I were to go down, let's say, into the capture thread here, my capture thread, once I've initialized everything and I do receive a packet, I'm going to actually send that. And if I were to dive down into this with a Control B, I'm going to be sending this to the destination, and that actually came in the request. It's not a parameter that gets passed. It comes in the RabbitMQ request, so that's why we don't have to pass that in. That's just the different way that I did it. And the nature of these things is a little bit different. These are short-lived, and they come to life only when we get a request. The request says, where do you want me to send this? And I send it. The monitors, on the other hand, you're going to be doing something like run monitor, and you do need to pass in as a parameter the URL to which we're going to send those REST replies. But both of these end up sending REST replies with the information, whether it's packet captures, traceroute, or device monitoring information, host scan, host monitor, etc. So not a whole lot of changes there in the worker code or in the monitors. Now what we'll look at next is the server code. So what changed in the server code? And the thing that changed in the server code is in this worker APIs. And in my worker API, when I'm going to start a packet capture, then what I'm going to end up doing is creating all of my capture information. So I'm passing in all this information. Oh, and by the way, I remember I said with the packet with workers, then we don't need to specify where we're going to send the results because it comes in the message. Here's where it comes. I keep doing that. Sorry about that. Here's where it comes in the message. This is the Quokka that it's going to get sent to. So wherever quokka-server is running, it gets its own IP address, and that's where we're going to send it. Now for send worker request, this is where we had to add something a little bit interesting. Basically, when we have a work request, I'm going to call find worker name. And what I'm going to do is I'm going to read in workers.yaml. And so you can see here I have my workers.yaml file. This is what we looked at elsewhere also. And what I'm going to try to do is I'm going to try to match this particular string, which happens to be an IP subnet address in my situation. You could call this, you could probably, if you're building this your own, there may be better ways to do this, but I try to do it based on the IP address, on the idea that we want the worker that is in closest proximity to whatever was requested. So if we are here in worker APIs and we're going to be doing, let's see, we're going to be doing a capture, or if we're going to be doing a trace route, or if we're going to be doing a port scan, the assumption is we're going to want to be as near as possible to where those instances are on the network. So we're going to map their IP address of the target to something here, and that is where I end up with my worker name. And this is the magical name that I gave. Remember when we ran it on my Raspberry Pi, this was the name that we gave the worker that was running. And so basically that is what's going to happen down here when we send the worker request. The only thing is that I'm going to create this thing called worker name, and then my queue is going to be using that worker name. And I also copied what they've done in examples, which is using the same queue name as the routing key. I don't know enough of the details of RabbitMQ. I've not used it at a higher level than the more simple stuff that I'm showing you here. So I don't know the differences between what the routing key might be for if you want to have a more robust and larger scale messaging service. You may want to have different routing keys, but that's basically the queue that we're going to put that in. And then over on the Raspberry Pi, when we run our working, it's going to be listening on that queue. So it's a little bit of code to make this queue decision. There's really no work on the monitor side, just on the worker side. And yeah, that is how we end up with this situation where we have HTTP information or requests for information getting passed in to our REST API, and then the message broker actually sitting here, and then we're actually going to be going and making a request and listen for requests for work. And when we get one, we're going to fire off one of these threads. The thread's going to run. It's going to send the data back here. And voila, we have a remote Quokka solution. So that's about it. That's how we implement remote worker and monitor functionality. Why would we do something like this? Well, one of the reasons why is so that we can distribute the work, so that the workload is spread. And another reason is for proximity. You want to be doing host scans probably in the subnet that you are interested in. Doing packet captures locally, you want to be doing that from the closest proximity to the thing you're trying to capture. And so you can do multiple of these things. We also mentioned that one of the nice things, because we use HTTP for sending stuff back, then you can actually separate your server from these remote systems. Now, it's a little bit trickier when you're doing RabbitMQ messaging. That's a topic for another lesson. There's ways to do that, and I've actually done that in the actual Quokka project that I built earlier on, if you wanted to look at that. But we do use just RabbitMQ in this situation. But still, it doesn't stop you from implementing this across some type of network, as long as you open the appropriate ports, etc. So that is some of the why that we would be doing something like this, and the how we did it. Basically, if we were to go back here, then the reason that the how is we're sending HTTP requests with all the information, and HTTP works remotely. So all I need to do is point it at my Flask service that's running, quokka-server, and it will work if it's running on the same system, and it will work if it's running on a remote system. And so that's how we have that particular thing set up. What code did I have to change in order to make it happen? The good news is I didn't really have to change any code except I had to change the hard-coded local host that I had for sending the data for all of this stuff. I changed that from being localhost 5000 to having that be a parameter that you pass in when you launch all of these monitors. And also I had to do a little bit of work, probably more work, just to make sure that my message broker was, number one, remotable appropriately, and number two, that we created this idea of different queues so that when you end up in a situation like this, every one of these workers will be running on a different queue, and the messages will be put into the message queue that is appropriate for the particular worker that is listening. So if you have multiple of these, they will all have different names. Those names I called worker names, and then that becomes the queue name, and that's how we get the messages for the work that's getting done. The device host and service monitoring stuff is a lot easier because it just runs independently and autonomously. All you have to do is tell it where to send the data that it's received. And so basically, because I did the design the way that I did, I remember when we were talking about it, I said one of the nice advantages of this design is that it makes it easy to make it a remote solution where you have remote workers and monitors, and this is that fruition that we're actually able to do that. Hopefully that made sense. I didn't gloss over it. I didn't go into detail about the workers and all that other stuff because I've done that in previous lessons. If you are unfamiliar with that, feel free to go back and look at lessons that talk about this stuff. But yeah, that's what a distributed solution looks like, and I hope that makes sense. If not, as always, just reach out to me via whatever means is appropriate, and I'll answer your question. Anyway, thanks for listening.